Greetings to all learners. My name is Naveen Yadav and I am a faculty of physics at SRN International School, Jagatpur, Jaipur. Today I am taking the topic electric field lines from the chapter 1 of Grade-XII NCERT. Reference book is Fundamental of Physics by Resnick, Halliday and Volker. In this topic, you will come to know about electric field lines and its properties. Electric field lines. Michael Faraday introduced the idea of electric fields in the 19th century. It was thought that the space around a charged body is filled with line of forces, now called electric field lines. Presently, the reality of these lines is no longer considered valid, although they were a nice way to visualize patterns in the electric field. The relation between the field lines and electric field vectors is twofold. First, at any point the direction of electric field, straight field lines, or the direction of tangent to a curved field lines gives the direction of electric field at that point. Second, the field lines are drawn so that the number of lines per unit area measured in a plane that is perpendicular to the lines is proportional to the magnitude of electric field. For a large charge, the electric field should be greater, and hence the number of field lines in space would be proportionality more. Thus, electric field is large where electric field lines are close together and small where they are apart. The number of electric field lines drawn from any charge should be in proportion to the magnitude of the charge. This is obvious from the second point above. So, in the figure, we can see a sphere of uniform negative charge. If we place a positive charge, test charge, anywhere near the sphere, an electrostatic force pointing toward the center of the sphere will act on the test charge as shown in the figure. In the other words, the electric field vectors at all the points near the sphere are directly radially towards the sphere. This pattern of vectors is nearly displayed by the field lines in the diagram, which points in the same direction as the force and the field vector. Moreover, the spreading of the field lines with increase in the distance from the sphere tell us that the magnitude of the electric field lines decrease as the distance is increased. So, if the sphere were consisting of uniform positive charge, the electric field vector at all the points near the sphere would be directly away from the sphere. Thus, the electric field lines would also extend radially away from the sphere. The field line from two equal positive test charges, as shown in the diagram, the pattern of field lines for the two charges that are equal in magnitude but of opposite sign. This configuration of the charge is called electric dipole. The charge attract each other because they are having the opposite polarity. The pattern of field lines and the electric field represented by it have the rotational symmetry about an axis passing through both the charges in the plane of the page. The electric field vector at one point is shown in the figure. The vector is tangent to the field lines through the point and it gives the direction of field lines. The electric field vector at any point is tangent to the field lines through that point. Now, we will talk about the properties of electric field lines. Electric field lines are confined by the following physical properties. First, electric field lines start from the positive charge and ends at the negative charge. This is the first property of electric field lines. Second property, no two field lines can cross each other because it is physically impossible for an electric field line to cross. That means no two electric field lines can intersect with each other. And if they are doing so, that means electric field line is having two directions at the same point. Third property, electric field lines contract longitudinally, that is attraction between the two charges of positive sign, and expand laterally, that is, a repulsion between like charges. Fourth property, the density of electric field lines at any point represent the strength of electric field at that point. Fifth property, electric field lines do not form closed loop because electric field is conservative in nature. So students, in this lecture you have learned about the electric field lines and their properties. Students, keep learning, keep signing, stay home, stay healthy. God bless you.